step one, what I did is all these little pieces of dried epoxy that are laying on the mold here, I'm running my hand over carefully. Here's one right here, in fact. These are just from being squeezed out of the mold. Because what I want to do is have the mold prepped. I always like to let the PVA dry before I lay up another part. But first I'm going to work on those new parts and see if I am going to be able to get away with 3 layers, or if I'm going to have to go to 4 layers or 2 layers, or vary it in some way. But I'll spend a good hour or so getting every sharp edge off, because what I think happened is when I here's a sharp edge right there. When I vacuum bagged this, I have a lot of little sharp edges, and maybe that was causing some leakage. See, and you can see on here where the epoxy has been oozed out, but that's what gives you the lightweight on one of these. Yeah, all the epoxy is squeegeed out, squeezed out, and absorbed by the bleeder cloth. So now that I know these molds work, I really want to protect these, and each time I use them, I'll sand all. See, there's a lot of sharp edges. I'll get all of this sanded smooth and get this pre-waxed again for the next layup. The most important thing is that edge. That's where I think we're really having a little bit of a problem. Because the bags, I'm sure I put, it doesn't have to be pretty, it just has to be that there's no little sharp edges here. Now luckily the other thing I've been able to use all of these tools that I got for Christmas have proved to be invaluable, every one of them. Get rid of the sharp edges. And see how nice that orbital sander gets right in those little corners and edges. No sharp edges there at all now. So I'm going to work that all over on the molds and then get ready to wax these up. After all that sanding, one of the things I thought might be appropriate here, and again I have to invent this stuff as I go along, or try to invent it is a better word. See, I just can't get, and I don't want to grind any more of that material away, so what I thought I'd do is mix up some epoxy, some 5-minute epoxy, whatever I have in stock, and just paint this and let it sit. Just put a paint coat of epoxy on there with the idea in mind that that would just give a smooth, the overall smooth surface. When it's in a bag, it's not going to pick up any sharp edges. I don't know, maybe mold makers do that all the time. Anyway, I couldn't figure a way of holding this, so what I did is I did the first half of it just using 5-minute SIG epoxy. In fact, what I had is some old epoxy that was out of code. It's all crystallized. Just warm it up. I wouldn't want to use that for building models once it's crystallized, but for this kind of an application, it's fine. And the heat will give it a relatively smooth. See, that side's already dry. This side is wet, and I'll do the other part. What I'm hoping, the heat will give that a nice, relatively smooth shine, and I won't be getting those little baby leaks in a vacuum bag. Maybe, maybe not. If nothing else, it'll make it just nicer to lay up the mold. And I'm going to remember this time to wax this side of the mold completely. Have plenty of wax on this side so I can pull that extra little beads of epoxy off. All part of learning. Looks like this is going to work out just fine. This really put a smooth coating on everything. There shouldn't be one rough spot on any place on these molds for the next pull. And the trick here was to take the last coat, I put 2 coats on here, 5-minute epoxy, and heat it with a hairdryer until it's like water. And make sure none gets on the other side, of course. But that should really protect the bag. And by the way, since we've been off camera, I have talked to Midgley about this, and he thought it would be an excellent idea. An excellent way to upgrade the molds is to have no sharp edges. Now while that epoxy is drying, I want to take and try to come up with the best way possible to get this line sanded in. And I thought one of the things I'd try to do is take some 3/4 inch masking tape and then try grinding. I can use the belt sander obviously, or try one of the hand sanders to try to get a relatively smooth transition line here. You can see the shape is kind of narrow, but I want to get a nice flat edge if I can. By laying out tape, it's just giving me a little guide, and the first thing I'm going to do is see if I can cut that line reasonably enough with a parting wheel. I had thought of a lot of other ways of doing this, but the first one, the most obvious one, is to just try doing it by hand with a parting wheel and see if I'm able to do that. In the past, whenever I've done any composite cutting, I usually like to rest this part of my arm up against my my chest, make this a solid, but you don't want to have your hands out in midair, and of course these. So you're resting your arms. That's usually step one. I'm going to see if I can cut this with just leaving a little bit of material on it, do the final little bit with a block. The idea is, and believe me, anybody I've shown how to do this, you need to have your hands pressed on something. You can't do them out in midair. Because every once in a while this will just catch and want to take off on you. And if I wasn't shooting video, I obviously would be using a mask. You don't ever want to breathe in any carbon fiber dust, ever. It looks like the way this is cutting, this won't be much of a problem. Now, I anticipated it would be more of a problem than that. That's a relatively decent cut, and the last little bit I'll do with a sanding block. Now, I wanted to try, because I don't really know this, but I'll try on the smallest piece to see how much of a scuffing I need to put in this smooth finish. I'm going to need to scuff it somewhat so that the Brodak primer will stick. And obviously, as soon as I get one of these pieces that's going to be ready, I'll make a little test piece. Maybe I'll make a test piece out of one of the scrap pieces. So what I thought I'd do is I'd just take some, this is 320, wet and dry. The edges came out real nice. That looks, I thought that was going to be a big problem. No problem at all. They block sand right in. Again, part of this is, and I don't expect, and a lot of people would, you know, be dying to change their whole modeling habits, but it's nice to have this as an option. Now, I'm already starting to think of how I want to do that motor mount crutch, because I really have never had good luck with radial mounts at all. I really don't like radial mounts. I have had no luck at all with rubber mounting the engine. So I'm going to basically try to come up with a variation of the good old-fashioned motor mount crutch that we've used for, but basically everybody's used for years. Now that's going to, when that's dry, that's going to be dull, but the edges are perfectly straight. That's what I like about it. It is, and it seems like, you know, as I'm putting this together, it seems like each piece that I'm making from these molds is getting better and better and better. So I have to think somewhere down the road I'm going to have really nice parts. Now that's got about the texture. I'm guessing I could even sand that more once I get some primer on it. But it needs a little bit of a tooth before I can put primer on a part like that. Parts to be very smooth so that they release from the mold, they just jump right out. Well, but then that smoothness hurts you. If you were to paint a part like this, even though we've washed all the PVA off of this, what would happen? You don't get a good mechanical bond to the paint, the primer, and we're going to obviously be using Brodak primer on this. But I don't know how much I'm going to have to sand. I keep thinking it's still wet a little bit. I keep thinking I'm going to have to sand even more than that. But until I do a test piece, I'm not really going to know. It's like that the coat on the mold is making it just about perfect. That'll be a whole lot better than it was, even though it's ugly. One of the things I'm used to doing, balsa wood and plywood parts on this sanding piece, and when you're doing carbon, it's just a little bit different. Well, it really holds a razor edge. I mean, when you sand in that final shape, this edge here is a razor blade, boy. You could cut yourself on it. Anyway, these are really coming out nice. Just getting rid of all that extra, and I'm sure that gets rid of some of the extra resin. Why don't we make this with a gel coat? Now, yeah, a gel coat has no strength. Gel coat just goes along for the ride. I'm hoping I'm going to be able to get away with maybe 1 or 2 coats of Brodak primer and go right into my finish. And from the way this is smooth, I mean, talk about a substrate. Wow, I don't know why I keep doing that. Anyway, very encouraging day. Now it looks like the tape method is going to be at least one good choice in terms of dressing this off. And then it still has to be hand finished, of course, with a sanding block. But at least I'm satisfied again that this is going to be a usable way of doing these parts. Need to develop this. So took and ground out. There was a couple little drips and drools inside here. But basically this is just a big hollow eggshell right now. And I'll trim around the nose ring and in the back, and then put that sanded finish on, and we'll be right back to where the other part is. See, that's a little, and this piece will come right out. It's just little defects in the what amounts to be that final layer. In fact, get this phone out of here. I'm coming to another conclusion that this last little bit of resin that's on the outside of the carbon is just going along for the ride. That I really want to have it like the tune pipes, the ultralight tune pipes. I want to see that last little bit of carbon right in the final shell to get the weight down as low as possible. The big one will be exactly the same redundantly, except I need to keep in mind that my center line came out in the mold, and at my center line, I'll check with the John Pothier tool that it's right even with a flat table. And I'll put that smooth sanded finish on everything. Now with just a minimum of sanding just to get everything rough, actually I'll figure a better way of doing this in the future, probably with some 320 wet and dry and some M600, but right now the sink is fine. I just want to see how much of a tooth I need on these parts. Anyway, we're going to pick this up tomorrow. It looks like we're a little bit closer to having what we want here. The shells certainly look like they're going to accept the prime with no problem at all. In fact, this little tooth I think is going to work to our advantage. The fact that we've got a nice tooth here from the sanding. And once they're flushed with M600, I think they're going to be real good. It looks like our molds here with the extra epoxy on them. They're nice and smooth, and we can start the waxing process on that tomorrow.
And digging huge air raid shelters in the local parks.
Anyway, I have my antique radio set to play Winston Churchill's speeches here. And of course we're in the wonderful Spitfire bedroom.
We just finished eating our tomato.
And what I'm going to do, I'm going to start collecting English music from World War II. I'm trying to put up a shelf here, but I thought this would be a great little listen to some of this English music. Anyway, I didn't realize they have this stuff on CD and tapes. Anyway, we're trying to make a bookshelf. I want to get all the stuff out from under the cot. And of course it's just, oh man, it's always a labor of love working on his bedroom. Another minor addition to the Spitfire bedroom. I don't know, believe it or not, Karen likes having these kits up here. This is one that John Brodak, actually both of them John Brodak gave me. Anyway, for all our next visitors, enjoy. The Spitfire bedroom awaits you. One low price breakfast bed, and you get to hug and kiss all the Spitfires. Now I want to just take 1 second. I know I've mentioned this before, that in my modeling career and the time I've spent doing this, I've never been happy with radially mounted engines. I've been really tempted to try again, because I know, of course, they use them in pylon, they use them in other events where they seem to work. But in this case, for right now, I haven't ruled out the possibility that I'll try to do a radial engine one in the future, but because jet and virtually all of the pylon engines, the PAs too, they use and they have available a rear mount radial mount that just bolts right in where the back plate does. So, but my first choice is to go with something proven. There's enough experimental stuff in this plane to begin with. And I really thought there was a future if I could make a mold for a carbon fiber crutch to possibly even use that on wooden planes. Sidewinder originally had a radial mount. It was soft mounted, it was hard mounted, and it worked the best when it was rock hard mounted. The soft mount, in my case, doesn't mean it won't work for other people, but in my case didn't work well. It's really fair right now to thank Jim Greenaway again for giving me all the information years ago, that the things that seem to elude other people, that a motor needs to be rigidly mounted. It can't be mounted in a piece of Kleenex and perform well. Rigid, solid mount. So that's what we're trying to get. And Jim basically years ago hammered that into my head, and I thank him for it right now. It seems like all the planes we've had with beam mounts, the motor run was always better. So this is the logic. I just want to go through the logic real quick, because this may look real easy when you watch it on video. Well, why didn't he just do this? Why didn't he just do that? Yeah, there's a lot of considerations here. At this part where the shells are complete, we haven't cut the hole for the wing yet, but we have a center line that's built right into the mold. Now, again, if I were going to be considering it, I'm not going to rule out the possibility possibly one of the future fuselages will try a radial mount. Yeah, that's fine, but for right now, there's so many experimental things in this plane that I really want to at least be sure I can get some flights out of this before I make myself crazy. I would like the mount to go back as far as possible. And what I'm going to try to do, traditionally we lay a crutch up with 2 pieces of hardwood and balsa wood in between. I'm going to try to mold this piece. First I'm going to make at least one balsa, plywood, aluminum, something that's the right size, that it fits right into that crutch. And I could envision that it might possibly wind up looking something like this when I'm done, because it needs not. I had 2 choices here. It might ultimately look like this, and it might be connected so that, let's just make a pretend thing up here. I don't know what this is going to look like, but then I can run the carbon, one piece of tow, right through the whole mold. It'll make it a whole lot stronger. Now, the other choice I thought of, and I've been thinking about these choices for quite a while, I just want to get the point across that I put a lot of thought into this, is to make a standard type of crutch. Of course, in here I don't need this solid. I can put, the best is always geodetic. I can connect it. But when I lay this up in the mold, I could put a hollow tube in the mounts, a carbon fiber tube. So in essence, I'd have hollow square mounts. Well, then the obvious question is, well, why not just make one of each and see which is the stiffer, the lighter, whatever. But anyway, this is the next step in it, and I need at least some amount of time to look at these parts. Because remember, I have to go right inside, and this is just wet from sanding it yesterday. I have a good texture, but the other thing now that I need to consider, and I need to figure out really exactly how to do this, or how I want to do it. 3 parallel lines we know are molded right into the mold. So in essence, lining up the plane should be relatively easy. And I've been tempted to cut the hole out for the wing, but I figure the longer I leave it in there, the more chance there is that when I cut it out, everything will be rigid. Maybe I can get the formers in the nose first. But anyway, I need to be able to line this up. Picture having this crutch, and even if it fits perfectly, it could go in like this, or looking from the front, it could be crooked in some way. So what I thought would be one of the choices I have, and these things take a lot of thought. A lot of times I can't tell you how much time I spend thinking about this because it's endless. I know this is a center line here, so I need to figure out an exact dimension front to back. And if I can somehow make a little jig, a fixture, a doubler, or something that maybe after I even make the crutch, I can glue that part right onto the top, and that'll be my alignment key. And then I bought a series of clamps. I can clamp this. The only reason for showing this ahead of time is there's more than, since we've never done this before, there's a lot of choices. And since it's so complex, to me it's complex anyway. Now, the last thing is, if this carbon crutch seems to be rigid and doable, and we're ordering some special, very special high-tech glue from Gail at CST, it may be that we could produce, that you could put right in a wooden fuselage, we could put one of these real rigid carbon crutches. And as I said, Paul Walker has told me that he already has carbon mounts in his B-17. It's certainly, and Howard Rush, I think, is the one that made them. It's not a question of, boy, did we invent this, or did Paul Walker? I don't care. What I care about is if we can make this part up, mold it, the next time you make a stunt ship, you can just pop that in, glue it with the special glue right to the sides, and maybe save 2 or 3 days of building and aligning, and it'll be perfect every time. So let's get down the shop. To get is a real accurate width of, I purposely made this that there's no taper in the fuselage except for the last little bit. So I need to get a real accurate width for what the motor crutch is going to ultimately be, because this is thinner than the 1/8 and 1/16 plywoods, and at this point in time, until we put structure in here, it's still kind of flimsy. Now what I did, I cleaned this out with some M600 just so I could get some clear fits as to how this is going to work. Again, we have to invent this as we go along. There's really no video that I know of I can buy that'll kind of do this for me. Now what I want to do is just oversize this by quite a bit, and then I can use the belt sander to get a final fit. It looks like the dimension I'm going to be working off is 2.5 for the plug for the crutch. I have a parallel. So the way I double check this, once I get it dressed off, take the old ruler, put a mark on it, you can see where the mark is, and slide it down the whole piece. That tells me that at least I know at this point in time I have an oversized piece that has 2 parallel lines. Just by looking at that, I know at least I'm close. Gives me a rough idea. And again, this is just going to be a template. This isn't even going to be the part. I want to know the distance front to back, the width of the mounts. We have a 1/4 inch piece of balsa, roughly the shape I'm going to be using. I know I'm going to have to taper that eventually, and I know I'm going to have to deal with making this the ultimate thickness that I want. But this is just giving me a template. Transpose that onto what I hope will be a part of the actual plug, a piece of 1/16 plywood. I'll cut that out with the Dremel saw. You always want to keep the original pattern for my reference, so if I want to make this thinner, thicker, whatever, I always have that option. I wanted to make the piece just a little bit oversized. So I left a little bit of extra material along the edge. Always better to have it a little bit oversized than a little bit undersized. The original template, the piece, and with that little bit of oversize, now I can just do a final fit on the motor itself. Cut up 2 little pieces of hardwood because this actually is, I want to use this to mount the motor, and I want to use the rest to be balsa wood. In the mold, of course, it won't know, and the plug, I mean, if it's hardwood or balsa, but I want a hard place that I can mount the motor to while I'm making this. Okay, now I know that is a relatively nice tight fit for the motor, and this will be the real tank shim is right here already. So many possibilities, I want to make sure I don't miss any of the obvious ones here. Now this looks like it'll be, well, I guess we're going to find out. Now what I need to do is fabricate what will be, this will actually go in the plane this way, but I need to fabricate what will be the shape of the motor mounts next. And I can do that out of balsa wood. I don't need to make that out of hardwood and do all that grinding and cutting. Use some ordinary 1/2-inch square balsa and I can fabricate some little angle pieces here. And of course I'll fill this in with a piece of balsa wood too. The dummy side rail, so the first part of this I'm going to obviously get that piece put in there, but I wanted to get the side rails put in and then I could make that connector piece a lot more accurately. A lot of times you're doing this and you get one step ahead and you don't realize, ooh, better do that first. Again, I don't expect this to really work on the first shot, but I want to find out all the stumbling blocks as I go along. Now normally a 1/2-inch square wood crutch weighs about 3 ounces. And I don't want this to weigh 1.5 ounces. I want it to weigh, you know, right around 3 ounces. But I want it to also be about, you know, several times stronger, if possible. I can go over to the belt sander and just trim this off with the belt sander so I have the thickness that I want, and then I can go back and lay in those parts. Cut these and put the angle in on the Dremel tool, Dremel saw. Now the idea is to grind that angle in real accurately. And of course it's just a question of trial and error. The next step is to obviously fit these in. Oh, they look fit pretty good. Now the idea of this is that we don't have a mount going all the way to the back. We have a constantly decreasing amount of material there. Now just tack gluing them in there. Once I know they're straight, then I want to dress this off with the belt sander. And I'll get the other one in. Make sure they're all parallel and even. This is not to have a stressorizer, a place where the material is very strong and then very weak. You want to have that amount of material decrease at a steady rate. Now this is just to pick up the high spots. I'll show you right away where the high spots are when we go to belt sander that off. I want to clean up. I don't want to have any sharp edges on this, because ultimately it's going to have to be really fine sanded, Brodak primed, and then polished, so I don't want to wind up with any rough or unnecessarily rough edges. Set the stripper for the thickness of the material, and then I can strip off all my ribbing and not have to do a lot of trimming. Start by just tracing out this back piece, and I can make a rib, even though I've made this longer than it has to be. Safety tip I thought I'd throw in here: whenever I'm not using this, I always take a chunk of scrap wood and put it over the blade. Many times I've reached into the box of tools and wound up with this going under my fingernail or something. This is a real good safety tip. Okay, now I need to lay out the other ribbing in here with the wood that I've already stripped. Now, the idea of any type of construction like this is to connect the corners. Make boxes and then connect the corners. That's the whole way a geodetic surface works. When you go to twist this, it wants to move the position of the corners. It's just geometry that's involved. It really is the best of all worlds, and I'm going to see if I want to just try to picture if I want to divide this in 3, maybe in 2, and then connect the corners here. Front former I'll make a little bit oversized. Remember, what I'm trying to do is get rid of a stressorizer. And I'll leave enough material that I can get a radius in that corner. A point in that corner is not what you want. You want a smooth radius. Okay, now what I decided to do is leave it even more accented because I want more of a radius in there. And I'll just put another former right behind here. Actually, what I could have done, always thinking of things you could have done. My whole life is a could have done. Could have just made it out of a thicker piece of wood, but this'll do since it's only a plug. Now I need to get a dowel with a piece of sandpaper up. Remember that radius is a big factor in getting rid of a stress riser, because if you have a corner, things always crack right in a corner. When we get to the final finish on this, I'll of course want to have a real nice radius in there. To start with, I laid it out in 3 equal segments, and I'll just put the formers in first and then connect the geodetic parts. Again, this is kind of a trial and error thing here to see if we're going to have enough structure in this. And of course we'll have to make a test part. See, every time you add a former or anything, especially when you connect corners, you see all of a sudden it turns out to be really, really strong. Now this is about tripled in stiffness just with that little addition. That was when you really see the stiffness. Now it's really rigid, and we only have one. We have to get the rest of these in here. Now I've left them all just a little bit oversized, and of course I'll dress that all off on a belt sander when I'm done. And one of the things I always try to do is get one angle just about the way I want it. You can do that obviously with a sanding block, then kind of sight down the knife, leaving it a little bit oversized. It's always better to make these a little oversized and just have them to be in essence, a press fit, and you can pick the part up without even gluing it. Now when you glue it, I want to get a little bit of a glue radius down at the bottom. Now the next step I want to do is I want to drill the motor mount holes in this so that the motor will be completely in position, and then I can go on to try to get some trial fits into the fuselage. Now a good way to do this, of course, is with a nice sharp ice pick, and it's a little handier on a rear exhaust engine than when you're doing it this way. Then if you're doing it on a side exhaust, and you have to deal with the side exhaust. I always want to allow for the ability to make a little fine-tuning adjustment on motor offset. I'd never want to make a crutch where it's so tight you can't move the motor just a little bit. Now what this will do is give us an ability to just temporarily bolt the motor, and even though I don't want to cast these in the final part, I want to be able to locate this part without having to just guess at where the motor will be in front to back and in my level position. Okay, now what this will allow us to do is try to get a trial fitting in there and just make sure. Now obviously some of this material's got to be removed, but from looking at the top here, I can kind of interpolate, and I can do it with a pen and figure out before I even try a test fit, that corner's got to come off. Okay, now because this is balsa wood and not motor mounts, I'll just take that over to the belt sander and just remove that right down. And see, I don't know where this material is going to wind up because we have this curve to deal with, but I'm just going to take a little bit off at a time until I can drop this into position and get some kind of a fit up here. And in the worst of all worlds, I can just remove it all. I'm certainly going to have to take more than that off, but that's a good start to get that curve in there. Even just a test for here can show me that I need to get rid of some more of that corner. Funny, you always need about 20 fittings here, and I can see this is going to be a back and forth thing. Because we've got a lot of taper up in the nose here. But I want to mold the piece. I want to mold that curve in there. So I'm just going to do the final fitting of this with a sanding line. In fact, this piece doesn't even pay to have on here. I can just remove that. Now, there's still material has to come off here, and this I don't want to take more than I have to off of there. I don't want to have to fill all that up with filler or with glue or something. Yeah, it looks like the easiest way to do this is to just leave this totally undersized and then fill that little gap with some glue and make a little horseshoe piece in there. That looks like that's going to work. Now I need to figure out again, I need to make some temporary parts that are going to hold this in place when I glue the real piece in. So I need to figure out the next thing, how I'm going to do that. I'll at least be thinking about it for a while. And I could, once this is installed and lined up, I can make a little horseshoe former that'll attach to this. And I want to leave a little radius here so I can fill that with some heavy-duty glue. We have this real high-tech glue coming, and of course that'll get clamped. Before I can lay up the mold, I need to plug the holes, because I don't want the liquid rubber to get in there. I'll plug that up, put a final finish on everything, sand it all out, and then get a coat of Brodak primer on this. What I did, I filled in all the corners, even though that looks a little sloppy, filled in all the corners with, just so it get a little more material in the corners, because where this will crack, it's never going to crack here. It's going to crack in the corners. So this kind of gives us a little more strength where we really need it. Sealed up all the bottom areas of this with some thin CA, just so I would have no cracks and crevices in there. And I want to sand this a little bit. And I'm going to lay a little bit of epoxy in the bottom of each one of these and just let it, so I get a nice smooth finish there. I don't have to seal all the grain in the wood that way. And it'll add a few thousandths in thickness and rigidity. Next step is using the Dremel, the sanding drum. I want to lighten all this and then put a final 1/32 piece here, so that the bottom piece will be solid. It'll be 1/32 plywood. And this gives me all the strength. I've got a lot of glue and epoxy and everything in the corner. I want strong corners more than anything else here. This evolved. I originally was thinking I'd leave this plate 16th, but then I wanted to reinforce the corners, and I couldn't think of a better way of doing it. And then what this will allow me to do is, I'm going to have the woven fabric in this dimension. What this will allow me to do is keep it to either 1 or 2 layers by having 32nd plywood. But using this really kind of, until you have a part in your hand, it's hard to decide, you know, when I move this, just how rigid it is. Wow. You don't know until you make the part. So a lot of this is like an ongoing thing. Nothing quite as pleasant as just before supper time smelling burning CA. That's how I manage to stay on a diet. Anyway, in one day we've made up what I hope is going to be, and we'll get a coat of primer on this tonight, I think. Unless we have a lot of phone calls. That's how you chew up your hands. Look at it. And that gives us the strength we want in the corners. Now see, this is 32nd plywood, so what I'm going to really try to give this the all-American try on doing, and I really have 2 choices. I want to pre-finish this, because otherwise I got to get in there with and try to get the final finish sanded. It'll be hard enough sanding all these edges, And this way I can get in here with my finger and put a nice smooth finish. Now the reason I want a smooth finish is so that this mold releases nice. I don't have a rough edge on the mold. So what I'm going to do is basically just pre-finish both of these parts before I assemble them and make the base plate for the mold. And I think having all these corners reinforced like this is really going to add a lot of strength and really the minimum amount of weight. And if it doesn't, we can take this apart. We can do the old keep adding a 1/64 of an inch until we find the amount that we're going to need. Of course, the last thing is I want to get a really smooth, relatively smooth finish before I even put the primer on. And then we're going to let the primer dry overnight. And I want to radius all these edges because this will be the part of the mold that we're going to pull up from. That's a pretty good day's work there. And this is the best material I've found for pre-finishing molds or things like this. Good old Brodak white primer. Okay, now our Brodak primer is dried, and the next step that I wanted to do, because I want to get a nice clean pull off the mold. Really, you're not going to see this part. This is just for my own satisfaction. But you get a couple of coats of Brodak primer on it, you let it dry overnight, and this is basically kind of standard primer technology. Just in this case, I think we had 2 or 3 coats on this. I just brushed it right on. There's no reason to spray it. You know you're going to sand it. Wipe it with a paper towel, and you can already see you've got a relatively, let's see if we can candle this now, relatively smooth kind of surface here. I don't need to make it a whole lot fancier than that, that's for sure. Now this piece may need a couple of extra coats because there's still little flaws in it that I want to sand around all the edges. Again, the object is not to make it real fancy. The object is to make it that it releases from the mold as well as I can possibly expect that to happen. Remember, a smooth surface will always release a lot nicer than a rough surface. So anytime I put into this, then the ultimate kick is that when this part actually gets installed, I'm going to have to rough this up so that the glue gets a good bond. But I can't cast that roughness in, or I'm not going to get the part to release the way I want. And this part will probably take a little time. I'll do it off camera. I want to get in all the angles and corners as much as I can. You can basically see how quick, you can almost see your finger in. It picks up a nice shine right away. Things that's proven to be real helpful. These real thin Bud McKnight sanding sticks, nail files, whatever you want to call them. I found that in getting in the corners, see, in getting in the corners here, I want to detail this part. And again, this is probably something that you'd spend a little more time than average doing, because I want to get that real clean release from the mold. That's my motive here. But to get in all the corners and angles, and it may be that we can make these for people that want to try using them on now what happens when you get to this, it clogs up. I just cut that piece off, and I eventually wind up with about 9 shots at this, and then I just go get another one. These are cheap enough, that's for sure. Or you could use sticky back paper on a piece of 16th plywood or something. But I want to detail this in all the corners and angles and edges. Again, one of the thoughts, the spin-offs from the Miss Ashley project, we certainly have been able to make a removable cockpit. That seems like it's in the bank. We know about carbon cowling, so even if the fuselage doesn't work, I know I can use that cowling part. But we don't know about the motor mounts, and I'll be real curious to know if anybody out there is really hot to trot to try one of these. If they send me their wood crutch, I'll make a mold and make a carbon crutch for them for the cost of the material. Of course, I'd like to know, see, then I could weigh the real crutch, the wood crutch, which I can't do in this case because half of this is balsa wood. I could weigh the carbon crutch against a hardware. And then maybe I'll just make one of my own for a cardinal or a Strager or something, just to see. But I can see that there'd be an application certainly in other areas. It's that spin-off technology that even if the whole plane is less than, like look at the real Miss Ashley, hey, the real Tsunami. These are planes that, basically had a lot of experimental stuff, and you don't expect total success, but you expect to be able to use some of it. These are these little straps that Paul Winter sent me. They're like carbide filled, but I found those to be real useful. Paul, you've got a good invention here at last. I guess this is one of the benefits. Now I've got somebody that's found something useful. This came from England, in fact. Look how nice that gets in the corner. But these are definitely useful. Now I know these are washable. I can just wash. These are kind of carbide-y. Boy, that gets in the corner nice. And if you can't get in that corner, I mean, picture trying to get your finger in that corner. What a mess it would be. Making sanding tools. I mean, that's one of the things that separates, like, new modelers from advanced modelers is that you learn how to use sanding. You'll learn how to use all tools. And what I did, I put this on a flat glass plate, glued it to our base plate, making sure I'd seal as much of this as possible. Now the next step is I got to go over to the, I guess I'll do that with a knife, just trim off the extra here. And I'm going to get that edge. See all these hairs where it ends. Then I got to glue this to a base plate, and I can start putting the final coats of primer on. Again, I'm really looking forward to making one from somebody else's crutch so I can compare. Maybe we got somebody out there, somebody we'll be looking forward to if somebody wants to make that wood crutch. And this is just an old desk drawer that I guess it's not going to fit that way. And I'll build a little box. First step on all this will be to glue it down, give enough clearance around the edges, and glue that right to the base plate. Again, this is just a piece. This is a desk drawer. And what I do is I just don't throw any of my desk drawers or anything away until I see. Don't throw any of this kind of stuff away. You can always use it for making base plates. Any Formica covered wood is an excellent base plate. One thing I know for sure, and I've made this mistake before, is I don't want the molding rubber to creep underneath the edge of this part of the plug. From the plug to the base plate, I really want to make sure I have a sealed joint, and I'll seal that even more with extra coats of primer. But I've made that mistake that when I've pulled it up, I've gotten a rough edge there, and obviously I'd like not to have that. Just let that dry without kicker. Before that glue, I put it really totally kicks off. I'm trying to get a little radius in the corner, and I'll put a couple of coats of thin in there. The thing is, I don't want to kick it off with kicker, because what happens is you get those bubbles jumping out everywhere. I'll just babysit this for a few minutes. Make sure that's down flat. We have a sealed edge. The most important part is to seal that edge. And what I'm going to do is I'm going to take this outside, and we're in the middle of a snowstorm of all things. I'm going to take it outside. I'm not going to take the camera out. Put a nice coat of primer around this whole thing, and then let this dry probably, well, the better part of a day, because we're going to be shoveling snow later today. Can you believe this? Obviously, anytime you're going to paint on a day like today, especially if you're looking to sand it within one day. Look at this snow. Ken Clapson, eat your heart out. My poor pond is under ice. Anyway, I'm going to have to go trek out there. Obviously, I don't have much of a choice today. We're just going to try to make the most of this snowy day here. Okay, this is what it should look like at this point in time. And we're gonna let that, obviously the next thing is to let this dry. Well, we'll see, maybe overnight. We gotta go shovel. We'll certainly have this up by the heating vent while we're doing our snowblower thing out there for the tenants. See you later. Once the primer is dry, this is the part that seems to take a lot of time. I've found steel wool to be useful in getting in all these corners and angles. Of course, you could do it with sandpaper. The idea here is to get a nice smooth finish on it, but not break through into the raw wood if possible. And I'll give this maybe 2 or 3 coats, and because it's snowing out there, we're really not going to go we're not going snowmobile riding today, that's for sure. But this is real handy for getting inside, polishing up little areas here that maybe you wouldn't normally be able to get to around the corners. And I'm guessing 2 or 3 coats of this is going to be enough. Again, you can even use this on Brodak dope. But I always seem to have a little bit better luck with sandpaper. Again, we don't need to make this like a buffed out part, but the smoother it is, the easier to release from our mold when we actually get to make the mold. Now, as a final thing, after the steel wool, the last coat. This is the SOS with the blue soap in it, and this leaves just the smoothest possible finish on here. Brodak primer and this material. Now I'm trying not to get this particle board too wet, and I want to go as much as I can without breaking through. Again, one of the thoughts I had was I want to try to make a crutch with the normal 1/2 inch or 3/8 mounts with a hollow tube cast right into it. I've thought about doing that as one of the choices. And once we have some of these made, we could start to see what they weigh. We can try the different resin system, the real high-end post-cured resin. We can try vacuum bagging one. Hey, we got a lot of choices here. And if they come out as accurate as we'd like, I'm sure it's a part we'll be selling in the future. And then we would only need to make a mold up maybe for a 40 size ship, and for a 60 size ship, possibly 2 or 3 molds that cover the whole spectrum if this becomes a practical thing. And it's amazing how things become practical in a big hurry, like the carbon fiber gear a year ago. It was a pipe dream. Now we're sneaking up on having about 200 of them sold. And I know they're all over the world. And we're going to be having another mold made very soon, probably within a month. We'll be doing 2 molds a day on that as one of a really good quality product that came from the world of molding. Now, I don't want to go through here, so I'm being real cautious. And then the last thing I want to do, I'll rinse this off, and I want to hit this with Gorham's. Now this is where the polywog with the little points, see, I can get one cut and I move it just down the sticky back paper. And all this is for is to get some of the extra sanding, the little detailing around the edges. Now as soon as you cut an edge, just move it up just ever so slightly. You get a lot more mileage out of the sandpaper that way. But that's the whole trick, having a set of those polywogs. Now I think one more coat of Brodak primer just to seal these little edges, and then I think we'll be able to cast up our mold. Okay, after this last coat of primer, you can see we're starting to finally get the kind of finish we want on the final mold. Now obviously the next step is to just let this thoroughly dry, and then we'll make the mold up, the box, and cast the mold. Now the last little thing is the last little dressing off of the edges. And this is the final thing before I make the box and pour the molding rubber. Now the best molding rubber I've found for this application is Smooth-On's rubber number 912. I've tried about 6 or 8 other brands that have nowhere near the easy to use features that the Smooth-On has. Anyway, I just want to, I'm kind of happy the way this came out. It's that edge I want to get nice and smooth, and I want to get this part in here nice and crisp. All these edges and angles, and they will add a lot to the structure. All right, we're ready to make the box. Again, this is the company if you're going to buy the molding rubber from them. Their telephone number is 610-252-5800, and it's Smooth-On 912, Smooth Sill 912. Time to make the box. Time to make the donuts. Of course, the idea is to make the box like a bathtub with this piece in the bottom. By doing that, all the air bubbles rise to the surface, and you should have a relatively good imprint. And I'm just using up ordinary scraps of balsa to make the box. One of the first times I made one of these little boxes, what happened is I had a pinhole leak in the corner, and I came back the next morning and all of the rubber had wicked its way out. So stuff is relatively expensive, so you really don't want to waste it, of course. You want to leave at least a ½ inch around the whole perimeter of the mold to give it some stability. Okay, we're ready to mix the rubber, 10-to-1 ratio. Always the most critical part of any mixing is to mix it exactly the ratio they call for 10-to-1, and stir it at least 2 minutes longer. When you think it's mixed, stir it 2 minutes longer. Stir it slow so you don't ingest any air bubbles into the mix. Try to wait till most all the air bubbles are out. And now the trick is to really pour very, very, very slowly and carefully. Very slowly. Because I don't want to miss any spots here. I want to get all around in all the little areas here. The idea is to not trap in any air in any of these confined areas like this, and I'll let this sit for 5 or 10 minutes before I pour any more. I want to get in all the deep little areas. Otherwise you wind up trapping air in there, and then you've basically thrown away a considerable amount of money of molding rubber. Not to mention your time and all of that. It's all going to drip down anyway, but you want to always pour it real nice and slow like this. Now, because I'm just a little bit short, I want to make the rubber rise up a little bit. I'll just put some 1/4-inch scrap balsa sheets along the edge, and that'll raise the level of the rubber so I can still see the impression. I don't want to make it a ½ inch thick, but I don't want to waste a lot of the rubber either. Just by putting those shims in, it makes the whole the level of the rubber in the mold rise up. With the 1/4-inch side, what we've done is compress it, of course, and that's going to sit overnight. Another trick when you're doing this is try to get it on a perfectly level surface so that you don't wind up with a wedge, you wind up with a relatively flat mold. We'll pick that up tomorrow. This is drying up and I got a little time left tonight. I wanted to do a little materials test. Materials test being, I want to see if I'm going to be able to make my bulkheads out of balsa material with carbon reinforcement, plywood with carbon reinforcement, just straight plywood, whatever. So I wanted to make up a couple little test samples of material here. And I just took average weight balsa nut, especially light, and I have a couple of scraps from laying up the first fuselage, and I want to try to lay those up right now just to get an idea of what these parts weigh. This is a real high-tech piece of material that I have, and what they do, they they vacuum bag this or put it under tremendous pressure so that the resin ratio is very low and it's very light. And obviously I can use this, but what I want to be able to do is maybe make my own equivalent material. Oh, that is light. Anyway, I'm going to try this. I also have a little sample of honeycomb that we're going to be using when Dave gets ready to, when that mold is ready, we're going to lay it up very similar to the way Kaz did. So a lot of what we're going to be doing in the next, here's a piece of honeycomb with carbon on both sides. We used some of this on the I-beam Spitfire. Very interesting materials to use. I want to try to replicate this. See, this has the honeycomb between two sheets of carbon fiber. The idea, of course, is with all of this, is to see if I can come up with an economical way of making the formers and bulkheads from a material that we already have in stock. This is actually the size of the part we have to make, and it's made, this part is made out of the cross grain stuff. So when we come to make this, I'll just make a sheet of this material a little bit. Actually, I could use this a little bit oversized. It's much thinner, of course. Anyway, I'm going to start doing my own little materials test program here. Make a blank from this to get an idea. Then I want to cover this with the carbon fiber on both sides, put it under pressure, and I can get some rough idea as to how heavy this is going to be. I have is a sheet of Teflon. I can lay that on the mold, on the base plate of the mold. I cut a little piece of material and a piece relatively the size that we need, and I want to make sure I have it soaked. This is 125 resin, 237 hardener. This is what's going to need to be post-cured to achieve its final strength, but we'll have plenty of time to experiment with this. Now, running these little tests, it may seem like, well, gee whiz, this is a lot of time and energy, but from this I will know, or hopefully I'll know, and I won't have to depend on any tech person to tell me. I'll know because I did the test myself, and that's the way I really generally in life itself, I like to operate that way. Remember, these tech people are always trying to sell you the product they have in stock, where if you do your own test, I think you're way ahead of the game anyway. Now we're going to have a Teflon sandwich here when we're done. It'll be a very interesting thing, and I can make up some scraps of other material just to see how this, since we now have a lot of scraps. And there may be some part of the model we can use this material for, or we can make our own carbon ply. When they make it, of course, they vacuum bag it, oven cure it, but it's $30 a sheet, so not so sure we can't make our own here. Here, all the resin will squeeze out. Now, if this looks promising, I'll make a little piece up and get Midgley to make me a little vacuum bag even. Now, what's important is I want the strength going this way, corner to corner. And I was real careful when I cut this to make sure I had it corner to corner. And see, this is big enough so I can weigh it against the part that I already have cut out.
No tears, no goodbyes. I'll just look into you.
Now, of course, the next step is put this under tremendous pressure. We'll find something really heavy, an anvil or something. Press out all the air bubbles. And when this cures, and after we post-cure it, we'll see what that weighs. In the little bit of time that was left over at the end of this mold, I was able to get this laid up. And I got 3 different thicknesses of material, one with the honeycomb, one with balsa, and one with just layers of carbon fiber. So I can get some good starting information on the material I'm going to use to make up all the bulkheads and formers that'll attach the wing and the bottom plate. We have all these carbon fiber scraps. It's a shame to waste any of it. I think we're going to be able to use them for this kind of testing. Now, yesterday we laid up this little part, and I wanted to get a grain weight on this part. And then this is 1/4-inch balsa with the lightweight carbon laminated on both sides and squeezed between 2 pieces of Teflon. Wow, is that strong! Holy mackerel! Oh, and it is. This piece is lighter than this piece, and this is light ply. This isn't even real plywood. So wow, there's one of the little test materials we made up. Now I'll cut that part, and then I can do a grain weight and see. But this is 2 or 3 times as strong. There's no way you can even bend this. So it looks like this will be one of our choices for future making up some kind of formers or whatever we're going to use this material for. This is the stuff we laminated, and this is 4 layers. You can see how nice the Teflon releases. Teflon leaves a nice, relatively nice finish. Now this is a little more flexible. It doesn't have the wood core. But again, I could make, you know, some kind of a case that, well, again, I'm just doing it by hand. This is definitely lighter too. So we're gonna wind up doing a little more experimenting. There's a lot of choices with this material. One of our tests, and as I pull this away, now this is the honeycomb center. I don't know, the best one of these seems to be the balsa wood. Wow. Seems to be balsa wood with this material on both sides. I mean, just as a gut feeling right away, that is by far the strongest. Now obviously these need to be post-cured. That'll add some more strength to it also, but honeycomb is an interesting material to use. Anyway, just something we're thinking about for the future before we wind up making a decision on formers. Plus, the way this all worked out, I'm going to need a lot of material for making formers up, and I was so happy the way that experimental carbon material, carbon and balsa combined, seemed to be a really good combination. So one of the things I decided to do here is I have this piece of glass, and it's perfectly flat except it's got a chip missing. Now I was using this for a sanding jig, but what I'm going to do is turn this into, I'll scrape this sandpaper off in fact, I'm going to turn this into a flat plate for making my own balsa carbon material, and it's possibly something that, you know, other people will want a piece of or whatever, and I can, when I lay it out, I can lay a whole sheet out in one shot that way. By the way, this is an excellent tip. If you've made sanding blocks with sticky back paper, or in this case, I've got the sticky back paper on a piece of 1/2-inch glass, and when you go to pull it up, it kind of tears into a million pieces. What you do, and okay, it's showing you how good the glue is. Just heat it. Of course, you can use a glass scraper and rip it in a million pieces, but if you just heat it with a hairdryer, you can do about 6 inches at a time, and it'll come right up. As you can see here now, we could even reuse. In this case, we could even reuse the sandpaper. You do about 6 inches at a time, it'll come right off. And then we'll have a flat plate for making our material up. Years ago, we used to put the sanding blocks in the oven at 150 degrees, and that would let the glue come off. This is a lot easier. And obviously now you don't have to throw the sandpaper away. Most of these sticky back glues release at a little over 100 degrees. Now, because I want to start with a perfectly clean glass plate, an old piece of, these are the kind of pieces of glass, because they're not that large. You can get these as, this I got as scrap from our local glass dealer. And I'll just give you an idea. You could build a tail on this, for instance, or whatever, and you don't tie up your whole workbench. It's got a chip missing in the corner. Doesn't bother me at all. Just don't cut yourself on. In fact, that's not even sharp. I want to start with a perfectly clean, flat plate. The little imperfection is going to be picked up in the in the part of material when we compress it. You know, what this allows me to do is make up this whole thing and get it off the workbench, and I can use the workbench for other projects, because obviously we need to do the work that normally goes on in a shop as well as modeling. Now, one of the things I want to try, I cut up 2 layers of carbon, and this is probably going to be the last thing I test today. I want to, you know how we do the old cross grain? Well, I got the best C grain piece of 16th balsa. So I have 1 grain going this way, 1 grain going this way, and that's balsa ply. Then what I'm going to do is squeeze this between, when I get that all laminated up, between 2 layers of carbon fiber and the high-tech resin, the 125, and then squeegee it all out with the idea in mind this I can use for some of the other composite parts that I'm going to have to make. And what are the, again, the only thing I'm trying to accomplish here is to try and find some material that's stronger than plywood at less weight. If I can do that, fine. If I can't, we just use plywood. I learned a while back in playing with this material and trying to use it, never sand the balsa before you actually put the carbon on. The little roughness gives it a nice tooth in between the balsa and the plywood. And this little, see, it assumes a curve. That won't matter at all in the final part. Once that's under compression. Composite companies sell material like this already made up. It's usually already oven cured and vacuum bagged and everything, except a piece like this would be $30, $35. So in this case we can make it up for maybe you know, $1 or $2 or something, I don't know, because we're supplying the labor. That's the reason. We've used one side of this Teflon. There's little microscopic dots of the epoxy on it, and we're not going to use this for a finish coat anyway. Get rid of all of that. What this allows an average modeler to do, assuming you have the material, use up your scraps and make a material that you can use in modeling that is definitely going to be worth, you know, as opposed to buying it, worth quite a bit. And like I said, if anybody out there really wants a little piece of this to test, send me the size of the piece that you need, and I'll cut off a little piece from some of these test samples we have. But this is the whole thing. It's like going to school. You have to make your own little test program. And I'm sure if, you know, if we were working on, let's say, a $50,000 motorcycle or a race car or something, we'd have access to this technology. We wouldn't have to figure it out. We just call up Shell Oil and they'd send their tech rep down here, and he'd show us how to do this. But obviously that's not going to happen. But a lot of times you think, another part of this, a lot of times you think, well, gee whiz, you know, that's too complicated or too complex, and then after you do it you say, wow, it wasn't so bad, no big deal. Now, one of the things I thought about doing, in fact, my wife was down here watching me do this the other day, and she says, instead of doing this, why don't you just get a rolling pin and roll it out? Well, I'm going to ask Midgley the next time I see him for some, you can see how much of this I can squeegee off. So when you're actually done, there's almost no resin at all on there. But a rolling pin, you know, a garage sale rolling pin, one of those marble ones, boy, that'd be nice. I wonder if they make such a thing as a Teflon rolling pin. Anyway, I find this to be really challenging. I find this to be, I mean, the reality is there's only so many wood aeroplanes you can build, and then you're doing the same thing over and over again. It's hard to keep your level of interest up. Okay, now we have most all of that squeegeed out. I'm gonna basically run off a couple of more of these things off camera. There's several other things I want to try. I want to try laminating a piece of this material right onto 16th plywood, 1/8 inch plywood. I don't know yet, but I want to have a good supply of this material when it comes time to cutting formers out. Now I'm going to try using the thinner material, the thinner of the Teflon papers. The idea of that is I can squeegee it down. I don't need that glass-like look, but I can squeegee out a, oh yeah. I can see I'm going to be able to get more resin out with the thin paper. You see I have a little bad spot up here. Cure that. What would be real helpful here would be to have another piece of glass and just park a car on top of this or something, or vacuum bag it even. Alright, we're going to leave that for a day or two underneath. About, some compression anyway. And then we'll have a good baseline of data so we can figure out, one of the next things, of course, is the material choice for the formers. Here's another thought. Anytime you're in doubt, I always leave that rubber sit an extra day and leave it by the heat. See, we're right up by the heating vent. Even though they say it cures in 24 hours, a lot of times they've lied. Do something with our scraps here that's of some productive value, and of course having this material, the sheet Teflon that I got from Dave Midgley, this is a big help too. Anyway, we're going to come back to this probably tomorrow and pull apart that mold. A little bit of time I had left over here. What I did, I made up a rough pattern of an oversized pattern of what I thought the tank floor would be, and the two doublers that'll go in the nose. Laid them up in exactly the same way and just put them under plenty of pressure, and we'll let this dry overnight. Remember how much fun it was when I was making up the 5-bladed props, doing the research on the material. And it was just one of the many things that I really enjoy about the world of modeling, making up these composite landing gear. Just some of the other projects, and it seems like even if you were to use a wood fuselage now, you could certainly use these carbon fiber plywood doublers. I was thinking of another interesting thing that would be worth testing if somebody out there wants to help me out with the test. The way they design an SV11, Randy Smith's SV11, it has that carbon mat up in the front, in between two pieces of balsa. Well, I wonder how this lightweight carbon would be when you laminate it between the doublers. Maybe I can talk to Bill Rich about this. Anyway, just another thought. So much of this, well, when you learn how to use a material, in other words, I would say in the first building of this whole model, no, it's really unrealistic to think you're going to make the first one jump out of the mold and it's going to be, totally without its problems. But the point is, from that first one, to learn enough that the second or the third one can be even better. But I'd love to know now. It'd be an interesting thing to find out. If instead of using 16th plywood, you used 16th balsa with the composite on both sides. Again, that'd be a fun thing to try. And I'm not so sure it wouldn't even work on a profile. That you couldn't laminate, let's say, 16th plywood and some carbon in that matrix. We're going to learn about this. We're going to do some testing. But obviously the first one is going to be the guinea pig we're working on now. And Dave has told me today he's making some real progress on the plugs for the wing mold. Again, I'm really excited about the idea that we're learning as we go, and I'm giving myself 3 years to learn how to use this material. If I do it in 2, that's even better. And it'll just be beginner's luck if I do it in 1, but I've certainly learned a lot in the last 6 months with the help of this guy, Dave Midgley. He has been one of the driving forces behind this carbon fiber development program. And of course, there's nothing at all wrong with traditional wood modeling. We just want to add whatever we can. And maybe ultimately what we'll wind up with is a hybrid where some of the carbon parts are in this, some aren't, or a combination of balsa and carbon. Time's going to tell. But I'm excited about finding that out. I just remember one final thing here. When we were doing the Spitfire project, and I told people I was definitely doing a fiberglass cowling. Ah, no good, too heavy. Oh, never work. Oh, it'll crack, it'll peel, paint will fall off. Well, needless to say, none of that ever happened. And so the time we spent developing, we spent 4 years on these Spitfires. The time, all that information is in the data bank now. And thanks to the video, we're able to show our experiments and the things that we've learned that haven't worked and worked globally now. Sets of fiberglass wheel pants, how difficult it is in the beginning. Now it's just a piece of cake. You can make wheel pants anytime you want. Now once we pull that mold apart and see if we have a usable mold, and of course if we don't, we'll just make it over. One of the things that I have now is the 125-226 hardener material, and that has some features that I may want to use on motor mounts. So first off, it doesn't need to be post-cured, and it's only about 2% in total tensile strength less than the real high-end stuff that needs to be post-cured. But what I'm going to do here is, if the mold is okay and I can pull it apart, I want to make one of each and see if... Now, what my theory is, this resin is a little bit thinner than this resin, and I may be able to squeeze more carbon into the mold. I don't know if this really works because I have to do the test to find out. But for sure, we're going to find out in the next week or so, assuming we have a good mold, because I want to make this one of the parts. I want to make several molds of things that we can, sell to the general public. And I'd like to use the best resin possible. Did a little test on our landing gear mold to see if I could make the gear a little bit lighter with the 226, and I can get about 2 grams lighter. But I don't even know if it pays because that resin is extremely expensive relative to the regular resin. But in the case of a motor mount, I think it really would pay. But again, I need to do the test. Our mold, and obviously one of the things you want to check right away on any rubber mold, I always let it dry an extra day and always put it by a heating vent, is that it's nice and solid. Because what happens, especially when you use up the bottom of the barrel, and which is what this was, the last of the barrel, sometimes it doesn't cure in the time that they tell you it will. Now I'd like to, since this is very thin around the edges now, because I put this extra wood here, it's kind of thin around the edges, so I want to real carefully pull this apart to where I just have the rubber shell. I know on a big mold like this, just break all the extra wood away, and obviously you could strip it down and use it over again. But this wood here now is really, I know the mold relative to the size of the crutch is very close because I was running low on rubber to begin with. So I need to maybe get a brand new blade around the edge here and peel this up very carefully. And this is the part that can get a little frustrating, is you really gotta, I know I'm cutting close to the edge here.
It's actually taken us about 4 years to get them to build it for us, but we're really
Whew. Oh, this is really, ooh, but I didn't cut the, see, a lot of times when you miss with the razor, you wind up cutting a piece. And I should have been more careful in cutting around the edge here. I picked away at all these little chunks of wood. I want to pull this up carefully, easily. Carefully, carefully. I was pulling that up. I don't care about that. This is the moment of truth when you find out if you're going to have to make another mold. No, this doesn't matter here. But I can see I've got this so thin at the edge, I'm going to have to make a box like a garage like I did for the nobler mold. I'll wind up making a box for this. Looks like we have a mold. Okay, now the next trick, of course, is to, we'll save this in our inventory of plugs. The next thing is to get a brand new pair of scissors and trim all this little edges. Now these edges are because I didn't seal that with, I could have put more primer in there, but I really didn't want. I didn't want to build big sloppy areas in there. That looks like that'll be a usable part. Now see these little things, you have to really do this just with brand new scissors. Next step is to make a box, because these are really flimsy. So I want to make a box that this will sit in. I don't know what this is, 3/8 balsa wood, 1/4 inch balsa wood. Anytime you make a box, you want to be able to just take that out, and I learned that when I was making the nobler cowling, which is still a pretty sophisticated cowling to lay up. I mean, for a beginner project, you don't want to start with doing a nobler. Now, just from looking at this, it looks like we've got this plenty over-engineered. I'm real impressed, real happy with the fact this is going to be probably stronger than we need it. Thinking about this, what I thought was this may be a little too flexible, and I have these nice 1/2 inch edges. I can just laminate these on here and make a box with 1/2 inch edges. You got the whole thing. You got to invent this as you go along. There's no 1-800 how do I do this. Roughed out the box. I just want to trim off all the edges and get it square. Then I'm going to have to think of how I want to protect this. Because obviously if resin gets in here, it's going to be a mess after a while. You've got to come up with some little invention for that too. And I want to have the height, exactly the height of the crutch, so that I can lay something on here for compression. Okay, now my little invention to control the height, I made up a shim that I can change if I want to make it a couple of thousandths, bigger or smaller, and I have a piece of the sheet Teflon. I have it backwards, of course. Now what that's going to allow me to do, now I want to get a piece of the real thin Teflon and cut it so it makes a little, I don't know what the right word is, epoxy proof it. Another little insurance thing, because remember what I know is going to happen for sure. Same thing with the garage mold that I made for the nobler cowling. I know I wound up with it, as soon as that extra resin gets on the mold, well then the epoxy sticks, so I'm just going to wax the whole thing here and leave the last coat of wax on. Just put plenty of this wax in here and then still put the Teflon sheet in just in case. And believe me, without Dave Midgley's help with all this Teflon, I can imagine if you had to do the research on the Teflon as well as this too, you could just go crazy. I guess I ought to get that lubed in. It's amazing. One drop of epoxy on this and you'll be tearing big chunks of wood out and everything. I'll take and put some extra wax right in the corner, just so we don't get this. I don't want to have this stick or whatever. I've learned the hard way. When you make a mold, don't take chances. Put extra wax and extra actually, I could put PVA on this too. I didn't even think about that. I will put the PVA on. I'll take any chance. I'm even going to wax the shim. If there's one lesson I've learned, and I've learned it over and over and over, never shortchange yourself on waxing the mold or putting on the coats of PVA. As soon as you try to take any kind of shortcut, oh man, I got a whole drawer of molds that didn't release the part, or oh my God. In the beginning, and I remember in the original, if you haven't seen the tapes of the original Spitfire videos when I was just trying to mold those little exhaust stacks, I'm just guessing I made 25, 30 molds. It was just ridiculous. I had a drawer full of them, and not one would release the parts the way I wanted them to, because I didn't understand how critical it was to get the wax and the PVA into the mold and get it in. Just get plenty of it on and take plenty of it off. Every time you do that at a molecular level, you're sealing the mold. And they recommend 4 coats of this, an hour apart, buffed out. Well, for this we don't really need it, but if this was a final part, that's certainly good advice. Now I'm putting that last little sheet of Teflon. I'm going to try to put this all together. Now I have the Teflon inside. This sheet, I don't know if this is going to fit. This is the way we're going to find out. I'll see if I can get this back in there. That'll really, I made this purposely a tight fit. Not getting this evenly in there. Actually, this is such an overkill by now. There we go. Okay, there we go. Now I can actually leave this piece over here. Now I'll trim it off. I'm gonna take a chance. Now I have that box with the Teflon piece inside. I'm just going to trim all this over, John. That should protect it some anyway. I didn't leave enough clearance for this, but I think this is overkill anyway. I'm just not going to even bother with it and go with this. It was squeezing it all together with this. I should have allowed, if I was going to do this, allow the clearance ahead of time. I didn't do that. Decided to do, after going back and forth with this Teflon, is just use PVA on a mold. I was going to not do this, but I guess in my quest to invent here, the Teflon just kept getting too wrinkled up and pushing the mold off to one side. And see, there's a problem with this mold already. I can see is I've made the sides way too thin because I was using up the end of the molding rubber. The next one I do, the sides will be much thicker, and I'll try to put some kind of reinforcement in there maybe, or make it that at least it's just solider. The PVA will definitely help in trying to get this out of the box if some of that resin drools down inside.
Admitted out as a Mustang, still is a Mustang, but they had to enlarge the cowling to house a Griffin engine with counter-rotating propellers. Whirljet is owned and flown by Wild Don Whittington and sponsored by Room Store Furniture, a company owned by my good friend Gary Levitz. What is the difference between a Merlin and a Griffin?
Then, of course, Gary Levitz. Wow. Every time I see his picture, I think, Miss Ashley, we're doing a little tribute to you, Gary. And that was the Whirljet that I think ultimately became Miss Ashley, going way back here. Love these videos. Before I lay up this mold, I'm just letting the PVA dry. I'll have this in the box. I have all the material I anticipate, and again, I don't know how many strands we're going to need. This is a starting point. I also have the real thin toe, and I have thick toe. And I also have a cap piece, which will be actually part of the tank shim. But to always have everything prepared before you mix the resin, because you have a time window with each resin system that's limited. You don't want in the middle of it have to run back and cut all this resin. Another thing that's a big help is have the shop conditions as cool as you can stand, because that prolongs the time that it takes the resin to kick off. Put several coats of PVA on here, Teflon on the bottom. I need to assemble this, of course, and then get ready to mix the resin. Inadvertently made this so thin, I'm just going to not take a chance and put just a few pins holding this in place. These pins can all come out once the mold is filled. You can see it has a little bit of a gap over there too. I want to pull that over. Totally unnecessary, because once I put this under compression it's going to squeeze out, but I think it'll just make filling a mold a little bit easier. And again, the problem that I had here, and you don't need to worry about it, just make the original box bigger and don't run out of molding rubber, and you don't have to go through this. And this is going to be the piece I'm going to try to lay in here. I want to make it a little bit oversized, that'll be fine. A couple of tips: once you mix any of the resin, you want to at least mix it 2 minutes longer. When you think it's mixed, mix it 2 minutes longer. That goes for any resin system ever. Another thing that's real helpful here, now you could put a little bit of black dye in here to make the part a little prettier. Right now I want the resin clear so I can see where the hard spots to fill on the mold is. That's another little option that we have. But one of the things I originally wanted to try is to put hollow tubes in maybe the next crutch project we work on. I'll try that. But for right now I want to know what this would weigh with no hollow tubes. So then of course I can compare if I have hollow tubes, or in essence I could put some balsa wood strips in here to act as filler. Like to just make one out of solid resin. See if this comes out weighing anything less than 3 ounces is going to be money in the bank. Then, if it's really rigid, I can thin these parts out. Any number of things, I can make it thinner here, there, or everywhere. But for right now, we need a baseline, and the baseline will be a solid mold. The trick I use is never mix more than 1 ounce of resin. If you mix more than 1 ounce at a time, what happens? It starts kicking off in the cup. The heat it builds up just makes it kick off so quickly that it defeats the whole purpose of it. Okay, so what I'm going to do first, of course, is paint the whole mold. And then start laying in those pre-cut pieces of tow. Again, we're shooting for, and I've made many crutches, 3 ounces is a half inch mounts crutch. I don't know what a 3/8 one would weigh, but if it's half-inch square, 3 ounces is a good weight. Of course, you can do there's every trick in the book to lightening up crutches, even wood ones, but if we can cast these, you would think there'll be a good chance that they'll all be relatively close to the same weight, as long as we can press in the same amount, use the same amount of resin. Again, we're going to find out. These are the things it's impossible to find out until you make a part. And since this is only going to be a test part, and the trick here is to pack the mold as tight as possible, get as much carbon and as little resin, and as few joints. Now once I get the bottom laid out, I'm going to try to take one piece and just keep going back and forth, back and forth. But for right now I want to lay out the whole piece. Get one strip going the whole length. And the more you can pack it down and saturate it, now if you do this adds, I've found this to be handy. Start at one end of the toe and keep pushing the resin away from the side your hand is on. And you keep squeegeeing it out that way. Just seems like it makes loading the mold a little easier than it normally is. Now down here where it tapers down very narrow, it's like doing a prop mold. You have to know ahead of time how many strands go in each side of the mold, or roughly. But for sure what we want to have is, on a motor mount, we want from one end to the other as many strands as possible going from end to end to end to end. Just like on a propeller, you want as many of the strands to go tip to tip as possible. Make sure there's plenty of resin in here. Now what I want to try now, and I don't know, be interesting to see if this is going to work. Put this on the floor. Now the first couple times I laid up a belt crank, I used this technique and it seemed to work. Again, any place you have a joint, there's a weakness. It's like where the bricks come together, and we can just fill this.
I'll just look into
I've been watching all these Reno Air Race videos. I finally got to see the World Jet. Finally have some video of the World Jet, which was before Miss Ashley became Miss Ashley. She was the World Jet, or parts of her were. I guess the wings weren't. Anyway, we're building that library up. Now we can just go, and this is kind of random, we just want to fill the mold. Printing resumed. Printing started. Boy, I got to thank Karen on camera for helping me with email. If it wasn't for her doing all my email, I'd be dead in the water here. And I say it without reservation, knowing full well that she's listening. She's a wonderful wife.
I just say that.
Ah, what's for supper tonight, honey?
This is Saturday. I don't cook on Saturday.
Oh, you don't cook on Saturday? We make molds on Saturday, huh? Saturday is mold making day. Be interesting to see if I went way overboard on making this strong or if I went way underboard. But you really don't know. And you see what I'm doing? I'm just using one strand here to fill the mold. And making sure that each strand is totally saturated with this resin. Now some of the resin systems are really difficult to get the resin to absorb into the carbon. The West resin is one of the better ones that I've used. Anyway, there's no point belaboring this. We're just going to be doing this for the next 15 minutes or so. Taking one piece and just going, and every so often laying in some more longitudinal pieces. And this really, really was labor intensive getting this to all lay in here. Now I don't know, I can tell by how much resin I've already put in here that this is probably overbuilt by a tremendous amount. Again, we won't know until I'm done, but I can just a wild guess be guessing that we have gotten a part here that's 5 times stronger than it has to be. But in developing a bell crank, it was the same thing. You'd have to go back and forth and back and forth. In fact, I'm going to trim this out now. Just a rough guess. And getting good at rough guesses here. Now I'm going to have to pull out, I'm going to soak this, pull out all the pins, and then cover this and squash it down, get it under some pressure. Now just like the bell crank, we'll make one that's way too strong, and then by having this piece as a plug, maybe this will become the plug for the next mold, the phase 2 part of it. Next step is to get out all the pins. Okay, the pins are out. And try to squeegee out as much of this resin as possible. Well, I know I've over-engineered this, but by having this piece, then I can grind away at it and see, maybe I only need half of the amount of reinforcements, maybe I need a third of the amount, I don't know. But you have to start somewhere. Even crossing the Atlantic, you got to put your feet in the water. Okay, I'm going to put this under another support and go put about 100 cans of Brodak dope on top of it. Thing I know, I have a rough count of how much tow is going to go into that mold if we ever do it again. I know how much resin, and I can write all this down. I know how many pins I need. But the main thing is, I had the best time of all seeing how many cans of Brodak dope I can stack on top of the mold under compression. We reached 8 and a gallon of molding rubber. And that is the record, by the way. So what do you think, Karen? Karen's planning our daughter's wedding here. She's on the internet looking up wedding dresses.
No.
What are you looking up today?
I'm looking up Vermont Country Inn.
Oh, God. I'm telling you, there's nothing better than Reno Air Race videos, a wife looking up a wedding gown, and Brodak dope compressing your mold while it sits overnight. Well, it quits for the day. This is the material we laid up the other day just to see if we could make some. By the way, I looked up the price of this stuff when it's already made. It's just out of control. There's no way even the most avid modeler could afford. Now see, here's a problem I had. I squeegeed out too much. I have a dry spot there, so obviously if we're going to use this for parts, we'll just skip that part, but it has a nice texture finish. And this is just balsa wood in between 2 layers of carbon. Another piece of material we have here. Again, I have to look. I was using a lot of heat when I was squeegeeing this out. Now, it may be that that's not objectionable, and you could use this on a glue joint part, but boy, I'm amazed at how this stuff is so rigid. It's just unbelievably rigid and light. That I don't know. Again, it seems like the best combination I can find is to laminate cross-grain balsa and then have my cloth going in an X direction. And by doing that, I got a lot of rigidity. This is probably many times stronger than a piece of 1/8" plywood, and about it's not even part of the weight.
You see, these 2 airplanes have been battling an
Piece to look at. I made up some like dummy doublers. I'll call them dummy doublers because I don't know how I'm going to arrange the doublers and motor mounts, but I wanted to have some material to look at. Now this is a piece of balsa wood between 2 layers of carbon, and I'm going to have to do a rough sanding if I'm going to do a glue joint. But last thing of the day is I want to put a dedicated box together with all my test materials. It's been very interesting, and I'll figure from this which of the materials, we've got a lot of testing, which of the materials are going to be appropriate for various other parts of the plane as we go to development. Okay, we're going to come back to this tomorrow. That'll sit under compression overnight. Now this morning I got up, took this out from under compression. Have our sheet of Teflon. And it looks like we've created the world's most over-engineered motor mount of all time. I wonder if you couldn't mount a Chevy V8 to this. Anyway, I'm going to obviously be real careful chipping this out, since we have. This is why I wanted to peel this up, because I knew this was going to happen. From my many experiences, we're going to have to be real careful about chipping this away. And that's why when I remake the next mold, I'll have to do this off camera. This is going to be labor, and I want to chip in all the edges before I pull this out. But one of the things, it looks like, well, the one side is beautiful. That's no problem at all. But I'm sure what's happened is we've over-engineered this thing, because I put in over 3 of the 1-ounce mixes of resin. I was hoping I'd get away with 2. But that's the way you have to develop a part, because now by having this part, I know how much the material weighs in this shape, and I can start grinding and cutting away all the extra until I have what I feel is going to be, you know, a final part. The other part of it is, I'm never going to know how much this part weighs till I lay it up, until you're finished with it and you make this first part. So it could be that from this part, I'll do all my grinding and cutting until I get it to the weight I want and make sure it's still good and stiff. Then I'll make a mold from this part. I have a lot of choices here. Next thing is to pull this out of the mold, though. is literally break the box away, because I know that when I replace this mold, I'll make this a lot thicker. Well, I guess if this was too light, it would be no good either. Ooh. Oh. Now I don't know how much of this material we're going to be able to take away. We certainly have over-engineered this. I don't know what this weighs. I'm going to go with a scale and weigh it, but well, I got to trim it off, get an idea what it weighs. We don't have any air bubbles in it at all, not that I can see. Here's the only dull spot down there. That's getting all ground away anyway. Oh my God, you could mount a Chevy V8 to this. Alright, the next step, after we have some nice breakfast, we're going to lighten that up, cut it away. And it could be, I'm just thinking things, it could be that all we need to do is put this in a milling machine and take an 1/8 inch, or in other words, with wood you need that thickness. Maybe with carbon you only need half of that thickness. This will be an interesting thing to try. Well, we'll learn something from it. It could be that we've learned the most significant thing of all, and just by looking at this, is maybe the motor mounts on carbon only have to be this thick all the way up. Could grind some of that away. A lot of choices here. But now that I have an actual part, and every time I grind some, I can twist this and beat on it and see, get some idea of where I can remove material before I make, and it looks like what I'll do is just make another mold from the final part and then be able to replicate it over and over again. Learning takes time. And Karen has a new invention. She made a mold. It's called a frying pan. She's molding pancakes. Carbon fiber pancakes. We have birds keeping us company for breakfast. Oh, another one. Oops, another one. They're all out in the trees now. Molded pancakes for breakfast. This is a rare mold. Took Karen years to develop the mold for these pancakes, to get them the right weight. Now, just to get a starting point, I know that this isn't trimmed yet, but we're going to start trimming it. We started off with the part weighing 124 grams. We're going to shoot for, hopefully get it down a lot less than that. But anyway, another thought. When you're doing molding like this, never be disturbed or discouraged. The first person that ever built a wood balsa plane probably had the same exact problems that we're facing. I'm going to go over to the bench, grind as much of this out as I can, and probably be back in about 2 hours, ready to give it another weight. Whenever you're grinding any carbon, you want to be sure to wear a mask. And in this case, as soon as I shut the video camera off, I'll get my good Wilson mask out. What'll happen is it won't be pretty when I'm done with it, but it'll be certainly a good base plate. It'll be a good base for my next mold, the next phase in this. 102 grains just by removing the flashing, so it looks a little more promising. I'm going to get all the material out of these webs and thin them out. And since we're coming up on the end of the tape, I can't put a lot of this, but I just going to get as much material as I can get out of there. Again, and each time I do it, oh, that is so strong. Unbelievable. It's unbelievable how strong this really is. Now this is where it would really be nice if we had, well, I think the first thing I learned here is I don't have to make this a 1/2 inch thick. This probably could be more like 3/8 of an inch thick for the next one. So even just taking little chunks like this out, little by little it gets light. I'm gonna take all of these out eventually. Removing a lot of the excess. Now, there is one conclusion I've come to right away. This part does not have to be a 1/2 inch, it can be 3/8, and I can remove a lot of this material. So what I'm going to try to do is grind out this, just make this part thinner in here, or if that doesn't work, I'll just commit to making a whole new mold. Unfortunately, we're at the end of this tape, and I feel like I've learned something very, very significant. I now have this part under 2 ounces. I'm going to do some final cleanup and dressing on it, but I want to change the design, and rather than grind away here, I have a little bit better idea of how I can make this now, and I think I ought to space these a little closer together. But now that I have a square one, if all else fails, I can go back and use this part. This is lighter now than a wood part, but I have a feeling, and we'll be doing this on the next tape. We're going to just re-engineer this up. I'm going to skip through it kind of quickly, because what most people really will want to know is, if they want to make their own, well, these are the final steps. Just clean up all the loose ends. In this case, now we have a square one. We have a 2-ounce crutch that looks to me to be indestructible, but now it's a square one, so that anything I can make another mold of and try, I can always go back and grab this one and grab that one. Having a square one, this puts me light years ahead of where I was when I started this video. I now have some real information and something I really think is going to pan out in the future, and may even pan out on the next mold. But this development stuff just takes time, and obviously it takes money. There's about $80 worth of stuff in this crutch. And hey, thanks for joining us. Please pass the tapes along, and if you enjoy this molding stuff, we're looking forward to developing more stuff. I love working with this stuff. And even though our first part was a little bit off, I'm sure the second one will be better, third one even better. Never give up. But see, here's the nice part. Now, if you decide you want to work on something like this, wow, I've already gone these first 2 steps. And what I thought was going to come true, I thought I'd be able to make these 2 ounces, has proven to be not only within reach, but we can do it anytime we want now. And that's a milestone in developing this. And of course, you could always use a wooden crutch. But having this, now you can use this crutch in a wooden fuselage. Well, a lot of choices. Now we can truly compare the carbon part to the wood part, to the carbon part, to the wood part, to the carbon part. We have some new materials to work with on the next tape. We have about 15 things that we've made. 2 different sizes of toe going into our project at this time. Times I think if I could only have seen into the future way back in the early 60s even. Harold Price was still alive. If he could be seeing some of this stuff we're doing now, he'd really be thrilled and entertained and impressed and whatever. But that's the cool thing about the future. You never really do know. And hey, we will see you on the next tape. One final note, I remember the frustration making these 5-blade propellers. Golly, was that a suffering, long time thing, but I finally got them, and I got to do the thing I wanted to do, is fly them at the Nationals on an official flight. It was really, really one of the milestones in learning how to mold carbon fiber. It certainly has been a long, long, adventurous journey, and I don't know what else you could ever do with your life that'd be more fun. And I'm glad to share it with you. See you on the next tape.